everyone, welcome back to Sulekha Physics classes. It is the most easiest way to learn all the concept of physics through this class. Today I am going to discuss about graphical representation of motion. It means how motion of an object can be described with the help of graph. Have you heard this word graph? Graph is nothing but it is pictorial representation of any two variable physical quantities. You know that when you study about motion, then you already studied that how distance changes with time, how displacement changes with time, how velocity changes with time. So today I am going to discuss all these things with the help of graph. In case of motion, there are two types of graph, right? Two types of graph. First one is distance time graph. And second one is velocity time graph. Now, I am going to discuss these two types of graphs one by one. Let us first start with distance time graph, or you can say displacement time graph. Only difference is that distance time graph gives speed and displacement time graph gives velocity. Okay, so let us start this one, distance time graph. It means how position of an object changes with time. This can be described with the help of distance time graph. To represent these physical quantities on the graph, first we require two coordinate axes. So let us assume that first one is x-axis and another coordinate axis is y, right? And in case of distance time graph, we always take time along x-axis, okay? Time in second along x-axis and this distance along y-axis, right? And distance is always in meter. Okay, one more thing, this change of distance with time, it gives what? Speed. In the same way, displacement changes with time, it gives velocity. So you can say that slope of this distance time graph gives speed and slope of displacement time graph gives velocity. Now question arises, what is this slope, right? Okay, to discuss about slope, first let's assume that this distance changes with time, like suppose this one, okay? This represents motion of an object. It means how distance changes with time. And again, suppose this straight line makes angle theta with the x-axis. So now here slope is equal to tan theta. Again, tan theta, you heard this term in mathematics. What is this tan theta? Suppose this straight line represents motion of an object, how distance changes with time, and you draw one perpendicular over the x-axis, right? Now, you know this tan theta is what? Perpendicular by base. Suppose this is O, A, B, right? So, you can write tan theta as perpendicular by base. It means AB by OB, right? And this AB is what? Distance, and OB is what? Time. So you can write distance by time. Y-axis by x-axis is distance by time. And you know distance by time is what? Yes, speed, right? Speed. So here we get slope of this distance time graph gives speed. You can write this, okay? This is very important thing, that slope of distance time graph gives speed, right? In the same way, slope of displacement time graph gives velocity, right? Now, so to discuss distance time graph, we always take distance along y-axis and this time along x-axis. Now, I am going to discuss about different cases of this distance time graph. Like suppose the body is initially at rest, after this it covers equal distance in equal interval of time, it covers unequal distance in equal interval of time. So we will discuss all these cases one by one. Note down first this one, right? Okay. So next, so let us take case 1, right? Case 1 is when the body is at rest. Rest means no motion, okay? Body at different time interval, body remains at rest. It is in rest position, okay? So now let us draw the graph in this case. Suppose time is along this side, x-axis in second, and here distance is along y-axis in meter, right? This is x-axis and this one is y-axis. Okay, when the body is at rest, suppose initially the body at time t equal to 0, the body is at suppose this 2 meter, okay? This distance is 2 meter. And after some time 1 second, suppose this is 1 second, this is 2 second, this is 3 second, this is 4 second. After 1 second, body remains at this position 2 meter. After 3 second, body remains at this position. After 4 second, the body remains at this 2 meter. Because the body is at rest, it does not change its position with time. So in this case, we get the motion of an object is this one, a straight line parallel to at x-axis, and this straight line, this represents motion of an object. Here the object is at rest, so it does not makes any angle with this x-axis. Here this straight line is parallel to x-axis, right? And if this straight line, this represents motion of an object, if it is parallel to this x-axis, time axis, then it means angle theta is what? It does not make any angle. Angle theta is 0. It means slope is what? Tan theta, right? So tan theta is, tan 0 is 0, right? Because tan theta is what? Y-axis by x-axis. Y-axis, there is no change in distance. Distance always remains same. The body is at rest. It's a stationary position. It does not changes with time. So there is no change in distance. So this slope is 0. And slope 0 means what? Slope 0 means speed of an object is 0. And it is true now, because when the body is at rest, it does not changes their position with time. It means its speed is 0. So this is the case when the body is at rest. Now, okay, note down. Now, second case, when the body moves with uniform motion. Uniform motion means body covers equal distance in equal interval of time, right? Okay. Hope you have written all these things. Okay. Now second case. Now case 2. when body is in uniform motion. We have already studied these things. Uniform motion. Uniform motion means body covers equal distance in equal interval of time. And in that case, when body covers equal distance in equal interval of time, what happened? Speed is constant. So you can write uniform or constant speed in case of uniform motion. Okay. So what happens? Here the distance covered by body is directly proportional to time. In equal interval of time, body covers equal distance. So in this case, graph is like this one. Suppose initially the body is at this point, time is along x-axis and distance is along y-axis. Okay, initially at time t equal to 0, suppose body is at this point. After time, suppose 1 second, here 2, here 3, here 4. After 1 second, the body covers suppose 1 meter. Okay, and after 2 seconds, body again covers next 1 meter, it means 2 meter. After 1 second, body covers next 1 meter, it means 3 meter. So when time is 1 second, body covers 1 meter, so point is this one. Next 1 second, body covers next 1 meter. Next 1 second, body covers next. In this way, when you join these points, you get a straight line. So in case of uniform motion, the motion of an object is a straight line, okay, passing through the origin when the body is initially at rest, 0 distance. And this suppose makes angle theta with the x-axis. So this straight line represents uniform motion of an object. Now the slope of this graph gives what? Speed, and in this case speed is what type? Constant speed or uniform speed. Okay, let us prove this one, how speed is constant in case of this uniform motion. Suppose at this distance 3 meter, okay, at what time? 3 seconds, right? And this at 3 meter, this straight line makes angle theta. Again suppose at 2 meter, when time is 2 seconds, again this makes angle theta with the x-axis. Again at this time 1 second, distance covered is 1 meter. At this time also it makes an angle theta with the x-axis. So at different distance this angle is same. Okay, angle same means what? Slope is same, right? And slope of distance time graph gives what? Speed. So if every time slope is tan theta, right? And here theta is same at all the time. At different distances this angle is same. It means change in distance with equal change in time. Body covers always, here time interval is what? 2 minus 1, 1, and here at this change in interval 1 second and 2 second, distance change is also 2 minus 1, 1 meter. When time difference is 2 and 3, it means 3 minus 2, 1 second. At this also change in distance is 3 minus 2, 1 meter. It means ratio is always constant. So slope and ratio of this y and x-axis is always constant. Y-axis by x-axis, right? And y-axis is what? Change in distance, and this x-axis is change in time, and it gives speed. So if this slope is constant at every time, it means speed is constant, or you can say uniform, right? And also you can write one more thing. In case of this uniform motion, the motion of a body is a straight line motion is a straight line passing through the origin, right? When the body initially at rest, and makes angle theta with the x-axis. This is the case when the body is in uniform motion. Okay, let us take one example in the same case. Suppose question is, this is a distance time graph of two bodies. Suppose one is this one and the body is this one. This is body A and this one is body B, and both these bodies makes, suppose body A makes angle theta 1 with this time axis and second body makes angle theta 2 with the time axis. Now question here is that which body moves faster, body A or body B? Now it's clear from the graph that which angle is more, theta 2. So here theta 2 is greater than theta 1. Theta 2 greater means slope of which body? Slope of B is greater than slope of A, right? And if slope of B is greater, it means speed of B is greater than speed of A, right? In this way, we solve the question. Okay, note down fast. Okay, now second case, when the body is in non-uniform motion, right? Next is this one. When the body is in non-uniform motion. Okay, this is third case, right? Now you know that non-uniform motion means body covers unequal distance in equal interval of time. So here also there are two cases. A, when speed of body increases with time, because it is non-uniform motion. So its a speed may be increase or decrease. And second, when a speed of body decreases with time, right? Because this is the case of non-uniform motion. Here the speed may increase or it may decrease, right? So in this case, when the speed of body increases with time, the graph is like this one. This side is distance, here is this side time in second, distance in meter. When the speed of the body increases with time, here the slope is like this one, right? And when the speed of body decreases with time, here is this side distance, meter, and time is in second, right? Here slope is like this one. Okay, these are the two cases of non-uniform motion. In this case, the body covers unequal distance in equal interval of time, and here at different you take this time at different time the body makes different angle. This time theta 1, okay, this time theta 2, this time theta 3. All these different times the body makes different angles. It means slope is different, speed is different. Here this angle is positive. So in this case, when the speed of body increases with time, slope is positive. Positive means speed of body increases with time. Slope is what? Speed. It means speed increases with time. And here at different time, suppose at this time body makes angle theta 1, at this time body makes angle theta 2, at this time body makes angle theta 3. So at different times again slope is different. but here this slope is negative in case of this case, when the speed of body decreases with time. Here slope is negative. It means what? Slope means speed. The speed decreases with time. So these are the two cases in case of non-uniform motion. Write down. After this, pause it and write down first. Okay. Now next one example in which all the three cases are there. Okay. Let us take one example. This is distance time graph, right? Meter. Here is time in second. Suppose initially the graph is like this one, then the body moves like this one, then the body moves like this one, and then again the body moves like this one. Let us take this O, A, B, C, D. Now identify the motion at different position. Here first OA. OA is what? OA represents what? The body is at rest at different time interval. The position does not change with time. It remains same. It means no motion of the body. So OA represents no motion. That is, body is at rest. Right. Now second AB. Here this is a straight line. This shows what type of motion? Right, uniform motion. AB represents uniform motion. And in this case, speed remains what? Constant. Speed constant. Okay, and in this case no motion. Speed is what? Speed is 0. Okay, now next BC. BC represents what type of motion? This one. Yes, non-uniform motion. And here non-uniform motion, slope is positive, so increasing speed. Non-uniform motion, you write variable speed. Okay, whether the speed decreases or increases, no need to write variable speed. Here speed is increasing. Again this CD. What does this CD represent? CD represents again at different time interval. The body does not changes their position. It means body is at rest. No motion. So in this way you have to solve different questions, identify the motion of the body, whether body is at rest, body is in uniform motion, or the body is in. So these are different cases of distance time graph. Next, second graph to represent motion of an object is velocity time graph. So after this one we are going to discuss about velocity time graph. Okay. Now, second type of graph is velocity time graph, right? It means how velocity changes with time. It can be shown with the help of graph. Suppose time is along x-axis here again, and velocity, what is the unit for velocity? Meter per second is along y-axis again. Okay, so we always take time along x-axis and velocity along y-axis to represent this graph, velocity time graph, right? And suppose at any time the motion is like this one. Okay, so this straight line gives slope, and slope of this velocity time graph gives what? Slope means y-axis by x-axis. Y-axis is what? Change in velocity, and time, change in time is on x-axis. So you can write change in time, velocity by time gives acceleration. So in case of velocity time graph, slope of Vt graph gives acceleration, right? And again one more thing, the area under this curve in case of velocity time graph, right? Suppose this is the area under the curve, and the area under the curve in velocity time graph is what? Velocity into time, and it gives distance or displacement. If it is a speed time graph, it gives distance, and it is velocity time graph, it gives displacement. So you can write area under velocity time graph gives displacement. Okay, right. Here again there are different cases when the body is in uniform motion, when velocity is constant, velocity increases with time, velocity decreases with time, it means non-uniform motion. So again there are different cases in case of velocity time graph. We will discuss again one by one, right? Okay, let us take first case. Velocity time graph for a body moving with constant velocity. Okay, or you can say uniform velocity. Constant or uniform is same. Uniform velocity. So in this case, what type of graph is formed? Velocity time graph. Suppose this side is velocity and this side is time in second. This is in meter per second, right? If the body is moving with constant velocity, so at different time velocity is what? Suppose at 1 second, 2 second, 3 second, 4 second, right? Velocity remains same. Suppose 2 meter per second or 3 meter per second, right? So at different time velocity is same. So graph is like this one. Here this straight line is parallel to x-axis, time axis, right? So in this case slope is what? If any line is parallel to x-axis, there is no angle. It does not make any angle with the x-axis. So here velocity time graph is a straight line parallel to time axis or x-axis you can write, right? And if any line is parallel to time axis, theta is 0. It means slope is 0. And here slope is what? Acceleration, right? So here acceleration is 0. So when a body is moving with constant velocity, if body does not changes their velocity with time, it means there is no acceleration. So acceleration is 0. You can also write uniform velocity or acceleration is 0. Okay. So graph is like this one. One more thing from this graph, if we find area under this graph, right? At any time, suppose from this time to this time, okay, 0 to this time, velocity is this one. So at any time, the area under this curve is what? Area of this rectangle is what? OA, B, C. Length into breadth. Length is what? OC. Time and breadth is what? Velocity, change in velocity. So velocity into time is what? Yes, displacement. So you can write area of Vt graph gives displacement. Okay. So this is the case when body is moving with constant velocity. Now next case, when the body is moving with increasing velocity or decreasing velocity, then what type of graph is formed? Write down. Okay. Now, second case, when a body is moving with uniform acceleration. There is acceleration in the body, but it is uniform acceleration, or you can say constant acceleration or constant acceleration. Okay. So in this case, velocity time graph is like this one. Suppose v is along y-axis and time is along x-axis. It is in meter per second. When a body is moving with uniform acceleration, it means there is a change in velocity with time, but change in velocity is equal in equal interval of time. There is an increase in velocity, but the change in velocity is constant. Suppose at 1 second, 2 second, 3 second, 4 second. Okay, right? Suppose at 1 second, velocity is 1 meter per second. Again in next 1 second, velocity is 2 meter per second. Again in 1 second, velocity is 3 meter per second. Velocity increases with time, right? At different time, velocity increases, but the change in velocity is always constant. And this change in velocity is constant with time. It gives what? Constant acceleration. So in this case, slope is like this one, right? And slope at different time, suppose at this time theta, again at this time slope is theta, again at this time slope is theta. This time slope is theta. At different time interval and at different velocity also, this theta is constant. Theta constant. Theta constant means what? Slope is what? Tan theta. If theta is constant, it means slope is constant, right? And slope constant means it gives slope of this velocity time graph gives what? Y-axis by x-axis, it gives acceleration. So acceleration is constant or uniform, right? This is the case for positive acceleration. Here the velocity of the body increases with time. In this case, suppose this is when velocity increases with time. So it gives positive constant acceleration. Now what happens when velocity decreases with time? It means final velocity is less than initial velocity, and if final velocity is less than initial velocity, this side velocity, this side time. Okay, it is in meter per second, it is in second. If velocity decreases with time, the graph is like this one, and in this case slope is negative. Slope is negative. It means it gives acceleration negative, right? And negative acceleration is also called what? Retardation. So this is the case for retardation. If acceleration is positive, then you can say simply acceleration or positive acceleration. But if acceleration is negative, then you can say negative acceleration or retardation, or you can say deceleration also. There is another term, deceleration. Okay, so here in this case velocity decreases with time, right? Now there is another case when a body is moving with non-uniform acceleration. What type of graph is formed in that case? Okay, pause it and write down all the things fast. Okay, next one is the case when body is moving with non-uniform acceleration. What type of graph is formed in that case, right? This is C part, when a body is moving with non-uniform acceleration. Or you can say variable acceleration. Okay, so what type of graph is formed in this case? Suppose here is velocity in meter per second, right, this side, and along this x-axis time is in second. Now in case of non-uniform acceleration, the graph is not a straight line, it should be a curve like this one, increasing non-uniform acceleration or decreasing, anything. But in this case graph is not uniform, it makes different angles at different interval of time. It means slope is different at different time interval. So this is the case for non-uniform acceleration, right? In this case you can write velocity time graph is not a straight line, right? It should be, that is, it is curve. It shows non-uniform acceleration. In this way, we can draw the graph for non-uniform acceleration. Okay. So, in today's lecture, we discussed about distance time graph, velocity time graph. So, three important points which you must remember, because that may be asked in 1 marks question or 2 marks question. Okay. First point is slope of distance time graph gives what? That is speed. So, you must remember these points. Slope of distance time graph gives speed, okay, or displacement time graph gives velocity. Second one is slope of velocity time graph gives acceleration. Yes, slope of velocity time graph gives acceleration, okay. And one more last important point, that is area under velocity time graph gives what? Yes, displacement. Area under velocity time graph gives displacement, okay. You must remember all these 3 points. It is very important, okay. Note down. So with this I am going to end the class. In the next class I will derive equations of motion with the help of velocity time graph. There are 3 equations of motion, right? So how they derive graphically with the help of velocity time graph. Okay students, so wait for the next video. Bye bye. Thank you.